First, let me start with the first one, that is the alkanes. Alkanes are the saturated hydrocarbons. So before writing the hydrocarbons which come under the alkanes, you must know the word roots. Word roots are very important, because if you are going to write any kind of hydrocarbons that comes under the alkanes, alkenes or alkynes, you must know their word root. That means the prefix of that hydrocarbon. Okay, the word roots are as follows. So firstly, it starts from meth. So meth is the first member. So that means whenever I say meth, it's a very simple one and easy to remember. That one trick which I am going to tell you now. Meth is nothing but there is only one carbon atom. Okay, whenever I say meth, there will be only one carbon atom. Second member is eth, and the third one is the prop. Fourth one is the but. Fifth one is the pent. Sixth one is the hex. Okay, so these are the word roots which you have to compulsorily remember with respect to your board examination. Okay, so among these word roots only you will get any kind of the formulas or molecular formulas or structural formulas, anything they may ask you. So these are the word roots. Very simple, guys. You have to remember, whenever it is meth, it should be only one carbon. Whenever it is eth, the structural formula or the molecular formula should include only 2 carbon atoms. Whenever it is a prop, there should be 3, and whenever it is but, there should be 4 carbon atoms. Once again I'm stressing you, so it should be 4 both in the molecular formula as well as in the structural formula, including the electron dot structural formula. Whenever I say meth 1 carbon, eth 2 carbon, prop 3 carbon, but 4, followed by pent is the 5th, and hex should have the 6 carbon atom. So now it's time to know this general formula of alkanes. I already told you the general formula of alkane is CnH2n plus 2. So now we are going to give the number. Now we are going to write the members of alkanes. Okay, so meth is the first member, I told you, right? So as it is first member, so N will be always equals to 1. Okay, so meth is the first member, so N should be always equals to 1 in the formula. So Cn, now N is equals to 1. So wherever there is N, let us replace 1 in the place of it. So C1 H2 into 1 plus 2. It is nothing but C1 is same as C. H2 1s are 2 plus 2 is 4. CH4 is the first member of the alkane. So how do we name the CH4 as? Very importantly, we want to understand. See, as I told you, the first member is a meth, and our saturated hydrocarbon is ending with ane. See, whenever it is alkane, there will be ane at the end. Ane is the one thing that you can remember, that whether it is alkane, alkene or alkyne. Whenever it is ane, it is going to be alkane. Okay, so now the first member is going to be meth, and the ane is combining with this, so the name is methane. Okay, methane is the first member of alkane. How do we write the structural formula? Very simple. Look at the molecular formula. It is 1 carbon atom surrounded by 4 hydrogen atom. So you know that I told you when I am telling about saturated hydrocarbons, that the saturated hydrocarbons have the single bond. Single bond will be there. So now the carbon will be having 4 bonds. Okay, and how many hydrogens are surrounded by it? 4 hydrogen. There will be single bond now. Okay, right? So this is how we write the structural formula for methane. So what about electron dot structural? So what about the electron dot structural formula? See, if we look at its electron dot, you have to write the valence electrons which is there for carbon. That is, the carbon is having 4 valence electrons. Okay, and we also have to write the valence electrons of hydrogen now. So hydrogen's valence electron is 1. Okay, so you can see now the carbon, as it has 4 valence electron, it need 4 more valence electrons to obtain the stability. So what does the carbon do? I told you that carbon cannot donate or cannot receive. Instead, what do carbon do? Carbon will share the electrons. By sharing, it is creating the what kind of bond? Yes, it is a covalent bond. So now what you can see that the carbon is having 8 valence electron, so that the carbon obtain the stability. Similarly, you can see the hydrogen is also having 2 valence electron. Why for hydrogen 2? It is because, see, hydrogen's nearest noble gas configuration is helium. Correct. So now hydrogen is having 2 valence electrons. So now what happened? So hydrogen also has obtained a stability. So this is how we will write the structural formula for the methane. The first member of the alkane is methane. I'm going to teach you the four members, the first 4 members of every the saturated and unsaturated hydrocarbon. 5th and 6th member, you try it. Definitely you are going to get it. Now let me teach you the next member of the alkane. I hope you're clear with this. Okay, if you're not clear with this, once again see, I'm going to teach you the second member. Definitely you can understand. Okay, now the second member. I told you the second member in our word root is eth. Correct. So eth is the second member. So in the formula, the n should be replaced by 2. Okay. So now the formula of alkane is CnH2n plus 2. Let us replace n is equals to 2. So n is 2 is nothing but C2H2 again n into 2 plus 2. Okay. So this is how we are going to substitute. So now C2 is nothing but C2 itself. We are not going to do anything else. We have to keep it as it is. H, 2 2s are 4 plus 2 is 6. So C2H6 is the next member. So the first member was the methane. First member was methane, correct? Its formula is CH4. We have learnt. Second, we got C2H6. Second member is who? Eth. So eth is combining with what? Ane. So it is ethane. Okay. So the ethane's formula is C2H6. So how do we write its structural formula? Very simple. Look at the molecular formula. How many carbon atoms are there? There are 2 carbon atoms. And please remember, I told you that in the alkanes there will be only single bond. So in between the carbon and carbon atom, you should create a single bond. How many hydrogens are there? 6 hydrogens, right? Remaining bonds are surrounded by carbon. And 1, 2, 3, 4, 5, 6 hydrogen atoms. C2, you can see C2 surrounded by 6 hydrogen atoms. Okay, so this is how we write the structural formula. This is the structural formula. Let me write, this is the structural formula for ethane. Now let me write the electron dot structural formula. Very easy, by looking at the molecular formula. Write 2 carbon atoms. And you know that each carbon atom is having 4 valence electrons. So 1, 2, 3, 4. And the opposite carbon is also having 4 valence electrons. Correct. You can see that. See, please remember that wherever there are 2 dots, that means only 1 bond can be created. 2 electron dots represent 1 bond. Okay. So here, as it is single bond, see that 2 dots are there. And remaining, it is surrounded by hydrogen. Hydrogen's valence electron is 1. Okay. So I am representing the hydrogen by star, so that what happened? There is some differentiation between the electrons. Okay. So now this is how we have written the electron dot structural formula for the ethane. You can also check whether they have obtained stability or not. See, this carbon is having 8 valence electrons surrounded by it. See, 1, 2, 3, 4, 5, 6, 7, 8. Let us put a circle for this. So now this carbon is obtained the stability. What about this carbon? Look at this. So this carbon is sharing, right, electrons. So this electrons also belong to this carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 valence electrons are surrounded by the second carbon atom also. And remaining hydrogen. Each hydrogen atom is having 2 valence electrons. You can see 2 valence electrons. Okay, so this is how we write the electron dot structural formula for the second member, that is the ethane. So please remember, when you are writing the names, it should be very appropriate. You should not write E or Y in place of A, so that the whole formula, structure, electron, everything will become wrong. Okay, so this A is very, very important when it comes to the alkane. So moving to the next one, the third member is a prop. Okay, so let me keep this as it is and write the prop below. The third member is a prop. So prop is a third member. So N is equals to 3. C3H2 into 3 plus 2. Because the N should be 3 now. We are writing for third member. So it is C3H2. 3 is 6 plus 2 is 8. So this is the third member. So our third member is prop, right? The third member is prop. And we are writing for ane. So it is ane. So it is a propane. Okay, very, very easy. Propane. So this is the molecular formula and the name of that particular compound. And now it's time to write the electron dot structural formula and the structural formula. So guys, you try with writing electron dot structural formula for this. Let me write the structural formula. It's very easy. Okay. So now 3 carbons. Let me write 3 carbon. Okay. And as it is ane, there should be single bond between carbon and carbon atom. Correct? And remaining carbons are surrounded by hydrogen. You can check here. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 hydrogens surrounded by the 3 carbon atoms. C3H8 is nothing but the propane. Okay, so we have learnt ethane. Also, the formula is C2H6. And we have learnt the propane. The formula is C3H8 is the formula for propane. I hope you understand this. Okay. And moving to the last, I'm going to teach you under the alkanes, the fourth member, that is butane. I hope you guys understood how to write the electron dot structure and the structural formula as well as the molecular formula for the first 3 members of alkane. In the examination, they will ask you, write the first member of alkane. So in the alkane, the first member is methane. Meth is there because we are going to write the single bond. Okay. Whereas the second member is ethane, third member is propane. So the next one we are going to write is the butane. So butane is the next member under alkane. But is nothing but the fourth member. So C4H2 into 4 plus 2. So our N value should be 4. So C4H2, 4 is 8 plus 2 is 10. C4H10 is the fourth member. Okay. So the name of this compound, C4 is nothing but but. It is but and alkane. So we are writing ane, butane. Okay. When it comes to structural formula, C4, write 4 carbon atoms. Okay. Alkane, right? So single bond between carbon. Next, surrounded by this carbon, we are going to write the hydrogen. So how many hydrogens are there here? C4H10. You can see there are totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen atoms are there. So I think you can try now for the to write the electron dot structure for both the butane as well as the propane, so that you will understand whether you have understood the concept or not. Now we have completed by alkanes. So next I am going to start with the alkenes, which is the unsaturated hydrocarbon. Now it is alkenes. Okay. So when I talk about alkenes, its general formula is CnH2n. So CnH2n is its general formula. So now as I told you that, so when I talk about alkenes, so they should have double bond between the carbon and carbon atom. I told you under unsaturated hydrocarbons, there are 2 things which we have learned. One is alkenes and one more is alkynes. So alkenes have generally double bond between the carbon and carbon atom, whereas the alkynes have triple bond between the carbon and carbon atom. So now as we are writing alkenes, okay, the carbon should have double bond between it. So to write the double bond, that means to write a double bond between the carbon, we need minimum 2 carbon atom. With the help of only single carbon atom, it is not possible to write the double bond. So we need minimum 2 carbon atom. So alkenes always starts from eth, not from meth. Okay. So the first member of alkene is ethene. Okay. So when I say eth, okay, then N should be always equal to 2. So let us substitute N is equals to 2. So it is CnH2n is nothing but C2H2 into 2. I am just substituting 2 in the place of N. Okay, so now I got C2H2 into 2 is equals to 4. C2H4 I got. So this C2H4 now is the first member of alkene. So then how can we name it? See, as it is eth, it is eth, and alkene is nothing but it is represented by ene. So eth plus ene is equals to ethene. So this is our molecular formula. This is our molecular formula, and this is the name of the compound. This is a name. Ethene is the name. So now it's most important time that you have to know how to write the structural formula for ethene. See, to write ethene, just look at the molecular formula. How many carbon atoms are there? There are 2 carbon atoms. Correct. So what is the main rule of alkene? There should be double bond between carbon and carbon atom. Okay. So let us write 2 bond between the carbon and carbon atom. So as the carbon is having double bond between it, so now we are done with the carbon. So what about hydrogen? So we are left out with 4 hydrogens. So now we need to write rest of the bonds between the carbon. There should be 2 bond between this carbon and other 2 bonds we have to write for this carbon. You might have a doubt that why we have to write 2 hydrogens on either side of the carbon, not 3 hydrogens on one side and another 1 hydrogen on the other side. See, it is very simple, students. You have to remember that whenever we are making the carbon stable, okay, whenever we are making the carbon stable, so there should be 4 bonds. Okay, 4 bonds is nothing but 8 electrons. Okay, I told you just some time before that 2 electrons is nothing but 1 single bond. Okay, so to make the carbon satisfy, minimum 4 bonds should be there surrounded by the carbon. 4 bonds is nothing but the 8 electrons. So now you can see this carbon is having 1, 2, 3, 4 bonds. So that means 8 electrons are there. The carbon is satisfied. I'll show you by writing electron dot structure. And this carbon also, see, it is sharing, right? So this also has 1, 2, 3, 4 bonds. This is how we write the structural formula for ethene. Another one thing is, see, let me write now the electron dot structure. So I told you that each carbon has 4 valence electron, right? So as it is creating double bond, 2 electrons should be focused towards the opposite carbon. So here also 2 electrons should be focused from the opposite carbon. So each carbon should focus 2 electrons. So one carbon has 4 valence electron, right? 2 is already done, left out with the 3 and 4. You can write above or below or above or sideways. Anything is your wish. Anything is correct. Okay. So now this carbon is also done with 2, left out with 3 and 4. Okay. Now both the carbons I have completed. Now both the carbons I have completed by their valence electrons. It's time to write the hydrogen. So hydrogen has 1 valence electron. Hydrogen has, you can see hydrogen has 1 valence electron. Okay. So this is how we write the electron dot structure for ethene. So now you can check, see this carbon 1, 2, 3, 4, 5, 6, 7, 8. So this carbon is having 8 valence electron. So now this carbon is having a feeling that it is satisfied. Okay. So this carbon, as it is sharing, these electrons are also related to opposite carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So totally here also it is 8. What about hydrogen? See, 2 electrons for hydrogen. 2 electrons for hydrogen. So this is how we write the electron dot structure for ethene. So now I am going to teach the next member under alkene, that is the propane. See, always you should remember in examination, if they ask, write the second member of alkene. Second member is prop, because the first member always starts from eth under alkene, because alkene need 2 carbon atoms to make a double bond. Okay, I hope you are clear with this concept. So let me move for the next one. So the next member is prop. Okay, because we have learned the first member under alkene is eth. So prop is the third member, prop, and our unsaturated hydrocarbon is ene. So under word root, prop comes in the third position. So N is equals to 3, C3H2 into 3. That means C3, 2 3s are 6. C3H6 is the molecular formula for propene. Okay, so now if we look at the structural formula for propene, so now if we look at the structural formula for propene, it looks something like this. So let me write C3, 1, 2, 3 carbon atoms. I told you when it is alkene, there should be double bond between any two carbon atoms. So let us write double bond between. You can write here or here. And I told you one thing you have to remember, each carbon should have 4 bonds. So this carbon is already done with 1, 2 and left is 3 and 4. And this carbon, as it is sharing, this bond is applicable for also this carbon. So this is also done with 2, left with 3 and 4. And this carbon is done with 1, 2, 3, 4. You can check that each carbon atom is having 4. See 1, 2, 3, 4 and again 1, 2, 3, 4 and this carbon 1, 2, 3, 4. So our C3 with alkene is done. So now left with 6 hydrogen atoms. You can see 1, 2, 3, 4 and 5 and 6. This is how we write the structural formula for propene. Okay, so now it's time to write the electron dot structure. So there are 3 carbon atoms, correct? We have to create double bond between any 2 carbon atom. So as a result of it, I am focusing 2 electrons towards the opposite carbon. This carbon atom is done with 2 valence electron. Remaining is 3 and 4. Each carbon has 4 valence electron. Okay, so this carbon, as it is focusing 2, it also has to focus 2 to create the covalent bond. So this carbon is done with 2 and third to bond with opposite carbon and fourth electron dot you can write either above or below. And this carbon is having 1, 2, 3 and 4. So everywhere we have written 4 valence electrons for carbon. So now it's time to write the hydrogens. So hydrogens valence electron is 1. So everywhere we are going to write the hydrogen. Okay. So there are 1, 2, 3, 4, 5, 6 hydrogen atoms. So this is how we write the propene. And let me teach you the one more under alkene, that is butene. Butene, but. Okay. See, but plus ene is equals to butene. Okay. So under alkene, the third member is butene. So now, as it is having fourth position, okay, N is equals to 4. C4H 2 into 4. So it is C4H 2 4s are 8. Okay. So C4H8 is the molecular formula for butene. Okay. So now it's time to write the structural formula. Very simple, guys. So you have to write 4 carbon atoms. C4, 4 carbon atoms. So in between any 2 carbon atom, you can write double bond. Let me now try with the middle. Okay. So I'm writing double bond here. I told you if it is a double bond, the double bond is applicable for both the carbons. Okay. So now this carbon is done with 2, left with 3 and 4. This carbon is also done with 2, 3 and 4. This carbon done with 1, 2, 3, 4. And this carbon is also done with 1, 2, 3, 4. So C4 and alkene is done. So now we have to write the hydrogen atoms. How many hydrogen atoms should be there? There should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So done, right? So will you try writing electron dot structural formula for butene? If you have tried and if you got correctly, do comment in the comment section. Okay. So this is all about alkene, guys. Now let us move for the next member under unsaturated hydrocarbon, that is alkyne. Okay. So it is also very simple. See, if you try writing one after the other, everything will be very simple. I will be discussing that in the exam oriented classes. Next is alkynes. Is alkynes. So general formula for alkynes is CnH2n minus 2. I told you alkynes are the unsaturated hydrocarbons which have triple bond between the carbon and carbon atom. So as it should create triple bond, it also need minimum 2 carbon atom. So I think you got an idea which is the first member under alkyne. Absolutely correct. It is eth. Okay, so the first member under alkyne is eth because it also need minimum 2 carbon atoms to create the double bond. So there is no methine under alkynes. So ethyne. So N is equals to 2 because eth is nothing but 2. The name is eth plus yne is ethyne. Eth plus ine is ethyne. Let us now write according to the formula. Eth is nothing but 2. So C2H2 into 2 minus 2. See, wherever there is N, I have replaced by 2. So C2, 2 to the 4 minus 2 is 2. C2H2 is the molecular formula for ethyne. The name is ethyne and its molecular formula is C2H2. Then how do we write the structural formula? Very simple, guys. See, C2, 2 carbon atoms you must write. Alkyne, right? Create triple bond between it. And remember, I told you that each carbon has 4 bonds surrounded by it. So this carbon is done by 1, 2, 3 and left with 4. You can write either here or top or bottom. It's your wish. And this carbon has 1, 2, 3 and fourth one is here. So 2 carbon done. Its triple bond alkyne is satisfied. So now it's time to write the hydrogen. So can you see C2 and H2 atoms in the structural formula? Yes, correct. So now it's time to write the electron dot structural formula. See C2, 2 carbon atoms. So as it has to create a triple bond, focus 3 electrons. Okay. And this carbon has done by 3 and left with 4th electron. 4 valence electrons, correct? And this carbon is done by 3, 1, 2, 3 and 4th electron is left out. Okay. So now each carbon has 4 valence electrons done. So hydrogen has 1 valence electron. Hydrogen has 1 valence electron. You can also check it whether it is satisfied or not. So this carbon 1, 2, 3, 4, 5, 6, 7, 8. So this carbon has 8 valence electrons. And this carbon also having, see, 2, 4, 6, 8. That means these 2, 3, 4, 5, 6, 7, 8. So this carbon also, okay, this carbon also has 8 valence electrons. So it's time to show for the hydrogen. See, hydrogen is also having 2 valence electrons. So this is how we write the electron dot structure for ethyne. Hope you got, okay. So next, let me start with the next one, that is the third one, but it is the second member under alkyne. Second member under alkyne is prop plus ine is propyne. Okay, so prop is the third member under word root. So N is equals to 3. C3H2 into 3 minus 2. C3, 2 3s are 6 minus 2 is 4. Okay, so C3H4 is the molecular formula for propyne. Propyne's molecular formula is C3H4. So how to write structural formula? See, C3, 1, 2, 3 carbon atoms. You can create triple bond. You can create triple bond between any 2 carbon atom. Let me write at the first only. So this carbon has done by 3 bonds, left with 4. This carbon has already done by 1, 2, 3. So don't confuse in this area. Very confusion for if you're writing for the first time. So as it is already having 3, left with 1, that will be bonding with opposite carbon. No need of writing above or below. This is done by 1, left with 2, 3, 4. So now there are 4 hydrogen atoms. So it is done. This is how we write the structural formula for propyne. So now it's time to write its electron dot structure. 3 carbon atoms. So as it is triple bond, share 3 electrons. 4th above or below or side, anywhere you can write. This is done by 1, 2, 3 now. 4th is to bond with the opposite carbon. And this is 1, 2, 3 and 4. Now it's time to write the hydrogen. 1, 2, 3 and also 4. 4 hydrogen atoms. So this is how we write the electron dot structural formula and the molecular formula for the alkynes. So if you have still doubt, do comment, do mention in the comment section so that I can teach you a bit easier than this. So now we have done with saturated and unsaturated hydrocarbons. It's time to move for functional groups. Functional groups play a very important role in this lesson, and it is really easy if you remember their suffixes and prefixes. So let me teach you the functional groups in a very easiest way. So let's learn the functional groups, okay? So when we talk about the functional groups, it's functional groups. So there are mainly 4 functional groups which you have to learn. The first one is alcohol. Second one is the aldehyde. Third one is the carboxylic acid. Carboxylic acid is the third one. The fourth one is the ketone. Okay, so it is very easy to remember. See, when it comes to the naming part, of the alcohol, so alcohol, in the name it is represented by OL at the end. In the name it is represented by OL. Aldehyde, in the name part it is represented by AL. Carboxylic acid is represented by oic acid. Ketone is represented by ONE. For example, see methanol, methanal, methanoic acid. See, we are saying all, al, oic. So that is how we write in the naming part. When I am teaching individually, you will understand even better. So now it comes to the molecular formula. So in the case of molecular formula, at the end of the molecular formula, alcohol is represented by OH, aldehyde is represented by CHO, carboxylic acid is represented by COOH, and ketone, see, in the molecular formula, it is represented by C double bond O. That means the oxygen is bonded to double bond. That means the oxygen will be bonding by using the double bond to the carbon. Okay, so this is how we write the suffixes in the case of molecular formula. What in the case of structural formula? Say in the structural formula, let me write in the short form. So alcohol is represented by a bond and OH. Remember, alcohol, aldehyde, carboxylic acid, all the three will occur always at the end. Okay, so CHO will be written something like this, C, H and O. That means this bond will be attached to that group of compound. Okay, CHO, O always will be with a double bond. In the case of carboxylic acid, COOH. This is how we write the suffix to represent the carboxylic acid in the structural formula. So in the case of ketone, as I told you, it will be represented by C double bond O in the structural formula. Okay, so in the molecular formula, extremely sorry, in the ketone place, in the molecular formula, it is represented by CO, not C double bond O. I'm sorry. For example, when I write propanone, so in that molecular formula, this ketone group will be represented by CO. In the structural formula, it is C double bond O, a slight correction. So this is the best way that you have to remember that how do we have to identify the alcohol in the case of name, in their molecular formula, in the structural formula. Similarly, the other also. Okay. So now it is time to teach you that each and every the functional groups in detail. So it is very easy to remember and the word roots remain same. Okay, firstly let me start with the first alcohol, that is the first functional group, alcohol. See, alcohol, I told you, in the name it is OL, in the molecular formula it is OH, and even in the structural formula it is OH only. So let me write word roots once again. Word roots start always from meth, eth, then prop, and then but, and then pent. Okay, so these are the word roots. Fine. So now when I talk about alcohol, the first member of alcohol is meth. So before writing the methanol, I would like to give you a small, very easy method of remembering the alcohol part. That is, alcohols generally have a formula. It's called as general formula. It is ROH. ROH is the general formula for alcohol. What is this ROH? See, R will be alkyl. I think you all know what is alkyl. See, alkyl is nothing but removing one hydrogen from alkane. For example, if we have CH4, this is alkane, right? This is methane. So from methane, if I remove one hydrogen, it will become CH3. So methane, now it becomes methyl. Methane becomes methyl. So by removing one hydrogen from the alkane, we get alkyl. It is represented by YL. Okay, CH4 becomes CH3, it is methane, becomes methyl. Okay, so now R is nothing but our alkyl, OH is our functional group. So meth, very easy to write the names, guys. Just write methane. So how to write the methanol? Just remove E from methane. For all the other functional groups also, you can follow the similar way. Just remove E from this name. Okay. So then add OL. So it becomes methanol. Okay. It becomes methanol. So now what happened? ROH. Methanol. Okay. So meth means how many carbon atoms? Let me first teach you to write the simplest way of writing the formulas. See, meth is now nothing but one carbon. Okay. So this one carbon is now getting attached to our functional group. I told you ROH is nothing but, okay, R is nothing but our alkyl. Alkyl means what? Removing one hydrogen. So now if in the case of meth, there was 4 hydrogen atom. By removing one hydrogen atom, I got 3. So CH3. This is my alkyl group. So this alkyl group is attaching to the OH. Now what happened? Methanol we got. We got methanol. Very, very easy to remember. Okay. So formula, by looking at the structure, very easy to write. CH3. C1, 2, 3. One carbon is bonded to 3 hydrogen and our functional group OH. So now let me show you what I told you at the beginning. See, methanol, in the name it is OL. In the molecular formula depicted by OH, and in the structural formula it is written at the end. Okay. Alcohol, aldehyde, carboxylic acid, I told you, it will be always denoted at the end. Let me now write the next one, that is ethanol. Ethanol. So eth is nothing but how many carbon? Write 2 carbon. And there will be single bond between carbon and carbon atom, remember. So all is there, right? Easily write OH at the end. Now we have written eth, 2 carbon. Alcohol group is also represented. Remaining place, now it is surrounded by hydrogen. Guys, there are so many ways to write. I am teaching you very simplest way of writing the structural formula. If you know the structural formula, very easy to write molecular formula. See, usually now we have 2 carbon, C2. Hydrogen, there are 5. You can count 1, 2, 3, 4, 5, and our functional group is OH. So C2H5OH is the molecular formula for ethanol. Okay, and methanol's molecular formula is CH3OH. So likewise, you try for propanol and butanol. If you're finding difficult, do let me in the comment box. So I will teach you those things also. Okay, it's a very easy, very, very easy. Okay, so now I think you got an idea that how to write the molecular formula, structural formula, as well as the name of the alcohol. Okay, so now let us move forward to understand the next functional group, that is the aldehyde. Now the next thing is aldehyde. Okay, let me write aldehyde. So this aldehyde is denoted in the name part, it is Al, and in the molecular formula it is CHO. In the structural formula it is like this, CHO. Like this also you can write, or you can write CHO. So both are correct. Okay, so now let me write the first, okay, meth. So before writing that, I told you that there will be a simple general formula to remember. So aldehyde has general formula RCHO. RCHO, but here R may be alkyl or R may be hydrogen. Okay, so this R may be alkyl or R may be hydrogen. What is nothing but this? You have some confusion, right? From where do we get hydrogen? Why do we have to write hydrogen is a very important task that you wanted to know. It is very simple, guys. See, you wanted to understand that. See, if the functional group itself is having the carbon, If the functional group itself is having the carbon, then that functional group will be substituted by hydrogen at the beginning. I'll tell you and I'll show you how it is. See, I told you R may be alkyl or R may be hydrogen. So the first member is meth, right? So meth, I told you that RCHO, okay, it may be alkyl. Let us try for alkyl. So alkyl is nothing but now CH4 becomes CH3, correct? So CH3, and if I write CHO, just I'm trying, okay? Let us see. CH3, CHO. Does it match the meth property? Meth is nothing but there should be only one carbon, right? You can see there are two carbons together here. Okay, so as it is having two carbon, we cannot write alkyl for the first member under the aldehyde. It is not possible. So that is the reason we have the substitution, that is the hydrogen. See, this is wrong now. Okay, so now meth. So methane, I told you just rub E, okay, and add Al. Methanol. So meth is nothing but one carbon, and that one carbon is already present in the functional group itself. So how do we write? So we usually write CHO like this. Correct? So this is our functional group. This functional group is just simply attaching to one hydrogen group. So what happened now? This is how we represent the methanol. I told you RCHO. R may be alkyl or R may be hydrogen. So if I write alkyl, we can't satisfy meth because meth is nothing but only one carbon should be there. There are totally two carbons here. So we are not going to write the CH3 group for the beginning of meth, that is methanol. Okay. So instead of writing CH3, we are just denoting it by hydrogen group. This is how we write the methanol. Okay. So how do we write the formula? Molecular formula is HCHO. HCHO is the molecular formula for methanol. Methanol's formula is HCHO. I tell you guys once again, because see, if I write CH3 here, totally two carbons it becomes. That is why we can't satisfy the meth property. If we have to satisfy meth property, instead of writing the CH3, we are just writing the hydrogen. Okay. So the R may be alkyl or hydrogen in the case of aldehyde. So this is methanol. Okay, remember our functional group itself have the carbon. So this carbon is considered. This carbon is considered. Okay. So now let me write the next one. So the next one is eth. Okay. So let me write ethane and just remove E from it. I told you, right? Add Al. It become ethanol. Okay. Eth means how many carbon should be there? Tell me. There should be two carbons, right? So let me write the two carbon. And this carbon is our functional group, because the functional group itself has the carbon. We need to take that for the count. Okay. So this is now my functional group CHO. Okay. So remaining now one carbon has to be surrounded by the hydrogen. Simple way of writing, guys. Very simple way of writing. Okay. See, eth property is satisfied. Al functional group is written. Correct. So now the molecular formula of ethanol is CH3 and CHO. Guys, remember, do not disturb the functional group. You should never disturb the functional group. If you disturb, no, some of the students, they may get confused. So always I suggest you not to disturb the functional group. Okay, ethanol. So one more I teach you guys. So that is a prop now. The prop. So propane. Rub out E and add Al. It becomes propanol. So propanol, how many carbon? 1, 2, 3 carbon. Guys, very, very easy. So 3 carbon. The third carbon is our functional group. Okay, CHO. So and remaining now, the carbon will be surrounded by hydrogens. Okay. So I'll tell you how this has been satisfied. See, prop 1, 2, 3 carbon. And the third carbon is our functional group. Al is satisfied. Correct? So now the formula is C2H5. See, 1, 2, 3, 4, 5, H5. And functional group is CHO. Sometimes, guys, see, if they add this carbon here only. So, and they add the hydrogen here only. So I'm just telling you, so I'm just insisting you for the safer side, like, no, you can write like that. no issues. They will give the full marks for you. Okay. So sometimes no, you may get confusion. So always I suggest not to disturb the functional group. Instead, you can keep like that. You can also write like this. See, C3H6O also you can write. Okay. So, but sometimes what happen, students may get confused that where is our functional group. Okay. So, to keep ourselves safer side, I always insist you not to disturb the functional group. So, this is how we write the propanol. See, prop 3 carbon, functional group CHO, remaining place is surrounded by the hydrogen. Very, very simple. Okay, so now let me teach you the next functional group, that is the carboxylic acid. Next functional group is carboxylic acid. Carboxylic acid. Okay, so in the name it is denoted by oic acid. I told you already. And in the molecular formula it is COOH. In the structural formula it is COOH. Okay, yes. So first general formula is RCOOH. So this R may be alkyl or may be hydrogen, guys. Here also why? Because see, our functional group itself has the carbon. That is the reason our R may be alkyl or may be hydrogen. So, first member is methane. Remove E, add OIC. Methanoic acid. Okay. So meth means one carbon only, and this carbon is our functional group. Okay. So COOH, our function. See, meth property is satisfied. COOH is denoting the carboxylic acid group. So our R is here hydrogen instead of alkyl. So the formula for methanoic acid is HCOOH. HCOOH is the formula for methanoic acid. Done. So let me move for the next one. Eth. So ethane, remove E and write OIC, ethanoic acid. Okay. So eth, 2 carbon, correct. And this carbon is itself our functional group, COOH. So rest of the 1 carbon is now surrounded by the hydrogen. So how can we write the molecular formula? Simple. Look at this, CH3. And COOH is the functional group. Do not disturb the functional group, guys. Don't disturb. Okay. Let it be as it is. Okay. So the one more I'll teach you, that is a prop. We call it as propanoic acid. Propanoic acid. Okay. Prop is nothing but 3 carbon. Okay. So this 3rd carbon is itself our functional group. So prop property is done. Methanoic, that is carboxylic acid functional group is there. Rest of the carbon is now written by the hydrogen. So this is how we write, guys. Very, very easy. Very easy. Okay. So in the molecular formula is C12, 2 carbon, C2, 5 hydrogens, H5 and CHO. So you can try for butanoic acid, pentanoic acid, guys. If you don't know, you can write again in the comment section. Definitely I'm going to help you. So this is now completed. The carboxylic acid group is completed. Now we are moving for the ketone group. Okay, the next one is the ketone. Ketone. Its naming part is represented by ONE at the end. CO in its molecular formula. In structural formula, it is C double bond O. So, see guys, you have to remember there is a general formula for ketone also, that is R1COR2. What is this R1COR2? See, I told you at the beginning of functional group that alcohol, aldehyde, carboxylic acid, they always occur at the end. But ketone, it always occur in between. Okay, so to occur in between, there should be something next to it, right? See, now I am standing here. So if I have to be middle, there should be one member next to my right side and one member next to my left side. So totally how many members should be there if I have to be in between? We need to be 3. Similarly, if ketone group has to be represented, minimum 3 carbon atoms should be there. Okay. So if 3 carbon means it is the prop. Prop is the 3rd member, right? So it is now prop. Pane, take out E and add ONE, it is propanone. So propanone is now the first member of the ketone, guys. Very, very importantly, remember methanol, ethanol is not the first member. Propanone is the first member for the ketone. So let me write the now structural formula. Prop, 3 carbon. Okay. There will be a single bond between carbon and carbon atom. I told you CO, functional group always occur in between. So now rest of the carbon is surrounded by the hydrogen, guys. Very, very easy. Okay, how to write a formula now? See, CH3, CO, CH3. Simple, guys. Very simple. Or you can add these two and keep the functional group. Okay, so this is also correct. Okay, so now let me teach the next member, that is butanone. Butanone. Okay, guys, butanone, how many carbon? 4, right? So 4, 1, 2, 3, 4 carbon. Correct, there will be single bond. See, as it has to be occur in between, guys, you can write the double bond oxygen here or here, anywhere. But it should be not at the end, it should be at the middle. So let me write the oxygen here. So now but property is satisfied. Ketone functional group is represented. Remaining carbon is now surrounded by the hydrogen atom. Okay. So we write CH3, CO, again C2, CH3. This is one way of writing, or you can write, see how many carbon? 1, 2, 3. Don't disturb functional group, guys. From the beginning I'm telling you C3, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen, and CO is our functional group. So this is how we write the ketone, guys. Okay, so we have completed the functional groups. Now leftover part is cycloalkanes and isomers. I'll teach you and complete this video. So cycloalkanes, cyclo is nothing but there will be cyclic closed chain, guys. So alkane, there will be single bond between the carbon and carbon atom. So our last concepts are cycloalkanes and also the isomers. Let me start the cycloalkanes. Okay, cycloalkanes. Cyclo, that means closed chain. Alkanes are nothing but there will be single bond between the carbon and carbon atom. What importantly you want to understand here is, if a cycloalkane has to be formed, if a closed chain structure has to be formed, minimum 3 carbon atoms are needed. Okay, so cycloalkanes, the formula is CnH2n. Alkenes and cycloalkanes formula remain same. Okay, so our first member eth cannot be to form cyclic structure. Minimum 3 carbon atoms. So it is a prop. Okay, propane is the first member under cyclo. How do we write the name? Propane combined with cyclo, it becomes a cyclopropane. Okay, so cyclo means a cyclic structure should be there. Prop means there should be 3 carbon. See, 3 carbon is written in such a way that it is having the closed chain. And each carbon is having now 2 bonds. Remaining is bonding with the hydrogen. Okay. So C3H6, you can see C3, 6 hydrogen atoms are surrounded by it. C3H6 is the, okay, it is the molecular formula for cyclopropane. Very easy, very, very easy, guys. You have to work out. That's it. Whatever I am teaching, if you just analyze, understand, work out, very simple. I am going to teach you the next member, that is a cyclobutane. Cyclobutane is the next member. So but means N is equals to how much? 4, right? So 2 4s are 8. Here I forgot to tell you. See, third member C3H23 is a 6. You can also take out the formula like this. So cyclopropane, so formula is a C4H8 because C N in the place of but is equals to 4. So C4 to 4s are 8. So write 4 carbon atoms in such a way that it should have closed structure. C4H8. See, we also satisfying the alkane property. You can observe here ane. That means single bond between the carbon and carbon atom. So we are writing the 8 hydrogen atoms surrounded by the 4 carbon atoms. So this is how we write the cyclobutane. You can try for cyclopentane and cyclohexane. The formulas are very simple. Just multiply. C5H2 is a 10. C5H10 is cyclopentane. C6H12 is a cyclohexane. It should be written in the closed structure. You can write this in another way, guys. See, you can also arrange the carbon in this way. See, in this way also you can arrange. But it should be a closed structure. That's it. So now we are moving for the last and final part of this lesson, which you have to understand. Isomers. Very, very important, guys. Isomers. Okay, the next topic is isomers. Sometimes it is also called as structural isomers. See, in isomers, very important thing which you want to understand is they have the same molecular formula, but they have different structural formula. Isomers are the compounds which have the same molecular formula, but they have the different structural formula. See, if you look at the isomer, let me write, before writing the isomer, guys, first you have to know the first member of isomer is butane, because isomers are nothing but the branched chains. Okay, to make branch, minimum 4 carbon atoms are needed. Okay, 2 carbon atom you cannot make branch, 3 you cannot make branch, 4 carbon atoms are needed. So the first member of the isomer is the butane. Okay, so isomer is nothing but now it is isobutane. See how it is having same molecular formula, I'll tell you. See, what is the formula of butane? It is C4H10. And even for isobutane, it is the same formula. What is the difference then? Butane and isobutane, what is the difference? See, butane, you are writing it just in the straight chain. You are writing in a straight chain. See, 4 carbon atoms are surrounded by 10 hydrogen atoms. Whereas isobutane, you are branching it. But when we write the isobutane, see, it is 1, 2, 3 carbon in the straight chain and 4th carbon in the branched form. 4 carbons are totally here, surrounded by 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 hydrogens. See, 10 hydrogens are there. Okay. This is how we write the isobutane. Isopentane, just you write 1, 2, 3, 4th carbon here, 5th carbon below. So let me tell you how to write the isobutane. I hope you have understood what is isomer. Isomers are nothing but having same molecular formula, shortest form I'm writing, same molecular formula but different structural formula. Okay, same molecular formula, different structural formula, we will call it as isomers. Okay, the first member of isomer is butane, isobutane. Okay, so one more thing I'll teach you under isomer is the isopentane. Okay, so what is the formula for pentane? I told you pentane, isopentane. So in the case of butane, I told you formula is same, molecular formula is a C5H12. Pentane's formula is C5H12. Even for isopentane also it is C5H12. So for pentane we write straight chain. Just we write 5 carbons and 12 hydrogens. Okay. But in the case of isopentane, see, we write like this 1, 2, 3, 4th carbon and 5th carbon. We branch like this. Just branch. Minimum 3 carbon should be in the straight chain. Remaining carbon atoms you can branch it. This is one way of writing. See, 1, 2, 3, 4, 5. Okay, 5 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen atoms. You can write hydrogens. You have to write hydrogens everywhere. Okay. Similarly, this isopentane also can be written in another way. That is 1, 2, 3, 4 and 5th carbon above or below you can branch. And remaining you have to surround it by hydrogen. So this is how we write the isomer structure. Very, very easy. First member, remember butane. And the last part, guys, you must know homologous series. What is meant by homologous series? You know, the homologous series are the group of compounds which have the difference of CH2. CH2 difference will be there. For example, let me now tell you, okay, let me just give you here, we have butane, correct? We have butane with the formula C4H10. Okay, and the pentane with the formula, just now we wrote it as C5H12. Guys, you observe here, C4 to C5, how many carbon difference? There is 1 carbon. C10 to C12, how many hydrogen difference? 2 hydrogen. So if the compounds which is having same molecular formula and if they differ by CH2 group, then such compounds are called as homologous series. So remaining content which is related to that means how to sort out homologous series, how to identify, all these things I will teach you in the exam oriented class. For now you understand the concept, what is homologous series? It is a group of compounds with a similar molecular formula. They have similar chemical property but they differ by CH2 group. Very important, guys. And guys, do share the video. So I took maximum effort to teach you the concepts in a very simplest way so that you have to score better marks in examination. Guys, if you like this video, don't forget to hit the like button, do share and do subscribe to my channel. Thank you so much for supporting me and see you all. Until then, bye bye.